So in order to graph the graph of f inverse of x, we're going to once again use the idea of transformations. So we need to start with our base function. So f inverse of x, the base function, has to be a good exponential friend from our previous section, and a good exponential friend from our previous section is y equals 3 to the x. So the things that we remember from the previous section is that exponential functions will have horizontal asymptotes, and y equals 3 to the x has a horizontal asymptote of y equals 0. We also know that it's going to go through the point right here on the y-axis of 0, 1. It'll go through the point over here in the first quadrant of 1, 3, and it's going to go through the point over in the second quadrant of -1, 1/3. And we have a nice increasing graph that goes through all three of those points. Now that we have that, then, if we focus our attention on the negative next to that x, in terms of transformation ideas, that means that we're going to have a horizontal reflection because we're multiplying by the -1 on the inside, in the exponent. So if I have a horizontal reflection, that means that we're going to reflect across the y-axis. So if I reflect about the y-axis, I'm going to start with my asymptote. Y equals 0 when I reflected about the y-axis is still y equals 0. The point 0, 1 is still going to be at 0, 1 because the point on the y-axis doesn't change when you reflect about the y-axis. But the other 2 points are the ones that are going to change. So 1, 3, in order to reflect about the y-axis, that means that I need to multiply the x-coordinate by -1. So 1, 3 becomes -1, 3. And the point -1, 1/3 becomes the point 1, 1/3. And 1, 1/3 is over here. And we have a decreasing graph. So now that we have this y equals 3 to the negative x graph, we're ready to think about what the subtraction of 5 does. Notice that that subtraction of 5 is on the outside of the parentheses. That means that it's going to be a vertical transformation. It means we're going to take our graph and shift it down 5 units. So everything that we're looking at here in this middle graph needs to go down 5 units. I will always start with my asymptote. So y equals 0, if I shift that down 5 units, I'm now going to have my horizontal asymptote of y equals -5. Now let's go ahead and take some of these other points and see what happens with them. So if I take -1, 3 and shift it down 5 units, you're going to notice that I'm going to subtract 5 from that 3. 3 minus 5 is -2. So we're going to have then the point -1, -2. Well, -1, -2 is going to be right there. So -1, -2. And then this 0, 1, shift that down 5 units, it's going to be 0, -4. So 0, -4 is going to be down here, 0, -4. And then 1, 1/3, subtract 5 from that y-coordinate, we're going to have then the point 1, -4 and 2/3. And we can go ahead and connect those dots with a nice exponential graph. So there we have our good old exponential friend. Now, as you look at the board, you're going to notice that I graphed this graph of f inverse on the same coordinate axes that I had graphed f of x earlier from part A. And the reason that the author wants us to see this is that once again there's a connection between the graph of f and the graph of f inverse. So let me go ahead and label this second graph as the graph of f inverse of x. So one thing that we talked about earlier was that if a particular point is on the graph of f, then when you take the x and the y coordinates and you interchange them, that point has to be on the graph of f inverse. So notice that happens. -4 and 2/3, 1. Over here we have 1, -4 and 2/3 on the graph of f inverse. We have negative 4 comma 0 on the graph of f, and we have the point 0 comma negative 4 on the graph of f inverse, and then finally negative 2, negative 1, and negative 1, negative 2. The other thing that we remember from earlier is that these two graphs have to have a very specific kind of symmetry, and it is symmetry about the line y equals x. So if you look at these two graphs, take the function f and think about its graph, take the function f inverse, think about its graph, and if you take those two graphs and you think about a mirror along the y equals x, you're going to see that we do have that mirror image going on. This piece has a mirror image down here, this piece has a mirror image up there. So the author wants you to see all of those different pieces associated with this particular problem, that there's a connection between these two graphs. The final pieces of information on this then are to think about the domain and the range and the asymptote for our graph of f inverse. So let's go ahead and finish off the problem and write down the domain of f, the range of f, and the horizontal asymptote for f inverse. So these should all be f inverses. So the domain of f inverse. Well, if we look at our graph of f inverse, this graph of f inverse goes forever to the left and it goes forever to the right. So the domain of f inverse is going to be all real numbers. And the range of f, once again, that's the y values that we use to create this graph of f. In order to look at this graph of f and think about its range, we go down to a y value of negative 5, but we can't go any further down than that. So, lowest we go, negative 5, and then we can go up forever. Once again, though, you never cross that negative 5, so I'm not using a square bracket there. I'm using a parenthesis on that negative 5. And then finally, my horizontal asymptote, once again, is y equals negative 5. Now, another interesting thing to note about the function and its inverse, if you compare the range of f to the domain of f inverse, we have exactly the same pieces. And if you compare the domain of f to the range of f inverse, again, you're going to see we have exactly the same pieces, because the range of f and the domain of f inverse are the same set, and the domain of f and the range of f inverse are the same set. Another interesting thing to note is that we had a vertical asymptote for the original function of x equals negative 5, and we have a horizontal asymptote for the inverse of y equals negative 5.